All right, today we're going to look at our last three shapes of our quadrilaterals that we're talking about. We're going to focus on our kite trapezoid and then the isosceles trapezoid. So we've looked through all of these shapes, and today we're going to focus on these three remaining ones. So we've talked about some shapes that come from a kite, but we'll talk specifically about just kite properties and then trapezoids and then a specific type of trap, the isosceles trap. First off, in a trapezoid, when you have a trapezoid, we're going to have one pair of opposite sides are parallel, which are the bases. So then the base sides are parallel. And then coming from that property, you have each lower base angle is supplementary with an upper base angle. So if I were to name these angles A, B, C, and D, that would mean that angle A plus angle B equals 180 degrees. And then separately on the other side, you would have another pair, which is angle C and angle D equals 180 degrees. And then in an isosceles trapezoid, we're going to keep the first two properties that we just had with a trapezoid, but then we are going to have the legs, which are the non-parallel sides. They are congruent. So we would have the left and the right side because we already talked about the bases being parallel. And then because of that, you have lower base angles are congruent and upper base angles are congruent. So the two angles on the bottom would be congruent to each other, and then also the two angles on the top would be congruent to each other. And then the last property deals with diagonals, and the diagonals are congruent to each other. So when I draw in my isosceles trapezoid, it breaks up into two pairs of congruent sides for my trapezoids. Kite is my last property. When you have a kite, you have two pairs of congruent sides. So we'd have these two sides on the right, and then separately these two pairs of consecutive sides. Next one is dealing with the diagonals. The diagonals are perpendicular, so we have right angles there. And then the diagonal that is in between those pairs of consecutive sides, you have it bisecting. So one diagonal bisects the other. And then also one diagonal bisects the angles. And then you also have then when we drew in our diagonal, because we're going to have a pair, we have one triangle on the top here in this case, and then another triangle on the bottom. We have one pair of opposite angles would be congruent. So in a kite, we have a lot of one diagonal or one pair of things doing something, whereas it happens in both cases in other shapes. So in an isosceles trapezoid, let's label this angle. First off, we have it's an isosceles trapezoid. So we're going to have parallel sides and then congruent sides. And then labeling in our angle, CDM is 6x plus 16. And then NCD is 8x minus 24. These are both angles that are up top. These are both upper base angles, so they would be congruent to each other. So I can solve for x by subtracting the 6x and then adding my 24, and I get x equals 20. When I plug 20 back in, plug it in right here, I get 136 degrees. It would be the same thing over here. But then it asks to find the measure of angle DMN. And in this case, these two angles are supplementary. So I would do 180 minus 136 and get the measure of angle DMN. Equals 44 degrees. In this isosceles trapezoid, parallel sides and congruent sides, IM is x plus 7. Make sure we label everything. KM is y minus 3. HM is x plus 5. And up top, we got IJ, the whole thing, is y plus 4. In an isosceles trapezoid, the diagonals are congruent, so this whole diagonal, y plus 4, would have to equal the entire other diagonal, which is x plus 5 and y minus 3. So when I simplify this one, I subtract the y on both sides. The y's actually cancel. And I get 4 equals x plus 2. And I get x equals 2. So I can then plug in my 2. I also know that this part and this part are going to be congruent. So x plus 7 has to equal y minus 3, but I also now know my 2. So when I substitute that in, I get 9 equals y minus 3, so y equals 12. And HK is the length of a diagonal. And so now that I have my y value, I can plug it in for a diagonal, which is y plus 4. Plug in my y value of 12. That means that each diagonal, including HK, equals 16. Next couple would be a kite. So looking at this one with a kite property. Within a kite, in this case, solving for x and y is this angle in there. That diagonal is going to split the triangle into the kite into two congruent triangles. So that's how I know that x and 114 are going to have to be the same angle. And then also that diagonal is going to split the 88 into two equal parts, 44 and 44. So then I know in this triangle, 180 minus 114 minus 44 would get me my leftover little angle over here, which is going to be 22. And then the other part is 22. So y is going to be 22 and 22, which is 44 degrees. For the next kite question, I'm looking for this angle right in here, and I need to remember that diagonals are perpendicular to each other, which means that that angle must be a 90-degree angle, so 6x plus 6 equals 90. Subtract 6. And then when I divide by 6, x equals 14. For this last kite, remembering that two separate pairs of sides are going to be congruent. Clearly 17 and 21 are not congruent, so it's going to have to be 17 and 4x plus 1 are congruent. But also 21 and 6x minus 3 would have to be congruent. So when I solve both of these, I can verify that x does equal 4, which follows my kite property rules. For these next few statements, looking over if these are always, sometimes, or never true. Remembering our diagram of our quad properties, is a square a parallelogram? Yes, no, or sometimes. A square always comes from, if we remember our quad family tree, so remember these shapes. Does a square always lead from a parallelogram? And the answer is yes, always. Do the diagonals of a parallelogram bisect each other? And yes, that is a property of a parallelogram. So that would be always true. For number 3, does a rectangle have to be a square? It could be a square, but it doesn't have to be, so that would make it a sometimes statement, because a rectangle does not have to go all the way down to a square. But a square does always come from a rectangle, so that would be always true. Are the diagonals of a quad perpendicular in just a quad? No, but in certain types of quads they are, so that makes it sometimes true. Does a parallelogram lead to a rhombus? It doesn't have to, but it could, so that makes it sometimes true. The diagonals of a rectangle bisect the angles of a rectangle, and not in a rectangle, but when you get to a square it does, so that would make it sometimes true. Is a square a rhombus, and does a square always come from a rhombus? And that is yes. And then going the other direction, does a rhombus have to go to a square? Not always. That would make it a sometimes statement. And then lastly, do the diagonals of a rhombus, are they equal to each other? And it is true only when it goes to a square, but it is true, so sometimes. So remembering not only your properties, but looking at this quad family tree is important to understand when properties are or are not true.